In this video, we're going to take a detailed look and an animated look at the formulas for earned value calculations that we'll often encounter in a project. So what is earned value and why do we use it? Well, earned value is a good way to see if our project is on, ahead of, or behind schedule, and on, over, or under budget. And then we can use these metrics to predict things about our project, like the future state. We can create an index out of our schedule variance and an index out of our cost variance, and then apply that to our original schedule and apply that to our original cost estimate and say, hey, here's where we think the project's going to land. So that's very valuable for mitigating risk or finding risk, or at least raising the possibility of risk to our project sponsor and stakeholder and say, okay, look, we're this much behind now. We think that we're going to need this much more budget or this much more time to do it. The earlier you can raise that warning, the better, because the earlier you raise the warning, the more mitigation steps you have, the more levers you can pull to mitigate. Either ask for more budget and get it, or reduce scope, or find other ways to do the work more efficiently. Either get, the rock star software developer, or find a team who can take off something like analytics and do that by themselves. So you get a lot more options. What you don't want to do in a project is say, well, we're behind now, but I bet we're going to catch up. Don't do that and pretend you're going to catch up. It's much better to raise the flag early and say, okay, here's where we think we're going to go. What do we do? And what's even better than that is coming with a plan. If you go to your stakeholder or your sponsor and you say we're behind schedule or we're over budget, help, then the project might start being called into question. On the other hand, if you say we're behind schedule, but our group lacked training in this and we've gotten them training, we should be good. Or if we can get them training, it will help out. Then you're giving a good option. Or we're over budget, but we found a way to do the work more efficiently if we do this. If we take this non-value added process out, or maybe we find skilled labor somewhere that can assist us. So come with some options and you'll likely get a better result. Now, we can compute these earned value metrics by hand, or we can use software to do it. So Microsoft Project does this very well, and I'll show that off in a separate video. What we want to do is we want to plan our project as we normally would do in project with a work breakdown structure and a Gantt chart. And then we're going to set a baseline. And then we'll frequently update that project plan with actual numbers, and magic, we can go to a special view in project and it will compute a lot of these metrics for us. But nonetheless, it's very helpful to know the formulas. The formulas for earned value are very much related and interrelated, and it's easy to get lost in them. So I think the best way to demonstrate this is with an animation, and we can consider how a typical project would go. So I have a shortcut here, the earned value formulas on the right, as you can keep track of what we're doing. First of all, we have rate of performance. So rate of performance is the actual work completed divided by the planned value. Now, let's think about how projects typically go. As much as we'd like them to finish ahead of schedule, that typically doesn't happen. They typically run behind schedule. So that actual work completed, if we were on schedule, would be equal to the planned value, and the rate of performance would effectively be 1. If we were running ahead of schedule, that AWC, the actual work completed, would be greater than planned value, and the rate of performance would be greater than 1. But we know that we typically run behind schedule, so the actual work completed will be less than planned value. And when it's less than planned value, the numerator is smaller than the denominator, and so the result, the rate of performance, is a number that is less than 1. It's a smaller number. Okay, now earned value, well, how do we complete that? Well, we take the planned value and we multiply that by the rate of performance. And guess what? If that rate of performance is less than 1, which means we're behind schedule, we multiply a small number by another number, and the result is going to be a smaller earned value. So if the rate of performance is showing we're behind schedule, the earned value is going to be a smaller number. If the rate of performance indicates we're ahead of schedule, the earned value is going to be a larger number. Now, what about schedule variance? So schedule variance is going to take that earned value and subtract from it the planned value. If the earned value is a small number and we're subtracting from it a larger number, then the schedule variance will be a larger number, but it will be a negative number to indicate that we are behind schedule. So we will reflect that as red. On the other hand, if we were ahead of schedule, then the earned value would be a larger number than the planned value, and the schedule variance would be a positive number, which naturally we'd reflect in green. Now the cost performance index. For that, we take the earned value and we divide by the actual cost. This is a bit of a tricky one because both of these numbers can change. We've already seen that earned value will be smaller if we're running behind schedule. But what about actual cost? Well, what if we're running behind schedule and our costs are greater than we anticipated? That actual cost is going to be greater. So there are actually two different variables at play here. If earned value is small and actual cost is higher than expected, then we're going to have a small number divided by a large number. And that's going to give us a small cost performance index. So notice earned value is reflecting the work that we've completed. Actual cost is reflecting the cost that we've incurred. In an ideal world, earned value would be big, would indicate we're ahead of schedule, and actual cost would be small. But most of the time, it's not unusual for earned value to be less than expected or less than planned, and actual cost to be greater than planned. And that's going to give us a small value for our cost performance index. Schedule performance index is similar, but instead of looking at cost now, we're looking at schedule. So this is going to be earned value divided by planned value. And we know we saw a planned value up here in rate of performance earlier. So we know that's what we thought we would have done at this time. If we're running behind schedule a bit, earned value is going to be a smaller number. And guess what? That schedule performance index is also going to be a smaller number. Now, estimate at completion. This is where we can use some of those indices to try to project out what the project is going to look like towards the end. So estimate at completion is going to be the budget at completion, or in other words, what we thought the budget for the entire project was going to be, divided by that cost performance index. So if we're running over budget, if we're overrunning a bit, that CPI number is going to be small. The budget at completion is going to stay constant, assuming we keep that number constant from our original estimate. A large number in the numerator divided by a small number in the denominator is going to give us a large result. So we see that as we're running over budget, we can do this calculation, and it's going to show that our overall budget for the project is likely to be such an order of magnitude greater. Now, estimated time to complete is very similar to estimated completion. And really that estimated completion, we should have the word cost in there, estimated cost to completion, because that's a financial number. Estimated time to complete is a very similar calculation because we're taking that original estimate and we're dividing by the schedule performance index, which remember, if we're behind schedule, that schedule performance index is going to be a small number. If we're ahead of schedule, it's going to be a big number. Typically, unfortunately, it's going to be a small number. Typically, we're going to run a little bit behind schedule. So if we take the original estimate as a larger number in the numerator, and we divide by the schedule performance index, which is a smaller number, in the denominator, we're going to end up with a larger estimate at completion. So that's kind of the ultimate goal, is to use these early metrics as a signal for how our project is going to end on schedule and on budget, where it's going to end compared to schedule and budget. Footnote, though, is that assumes that this trend is going to maintain through the duration of the project, which may or may not be true. It could be that we found that it was a tight labor market. We had to pay a lot more for software developers, for instance, or engineers. And yeah, okay, then we can project that out. Or it might be that we took this team of experienced people. We thought that with their experience, they would be able to accomplish maybe 70 velocity points in a sprint. but in reality we found they were only able to accomplish about 50 in a sprint. And then we can use that schedule performance index to effectively take that lower velocity number and plan out the rest of the project. But that is a bit of a lofty assumption, because we also know the learning curve theory means that as we do things, we tend to get better at them. So we want to keep that in mind. And we also want to keep in mind any other budgetary influences we can have. Perhaps if it's a tight labor market where we're operating, well, these days there's a lot of remote work, and perhaps we could source that labor in a cheaper market, although we'd have to consider experience and lots of things like that. So there are levers that we can pull, and these earned value estimates will help us determine when we need to pull those levers. Now that we've had some experience with the formulas, let's practice a little bit with some numbers. So I have a project here, and I have a budget at completion of $10,000 and an original time estimate of 90 days. So first of all, this earned value calculation we see on line 4 is the planned value times the rate of performance. And this kind of gets into a circular formula, because the rate of performance says how much did we get done. And we can compute that by looking at the actual work completed divided by the percentage of work that was planned at this point in the project. Because typically this is a control exercise. We're in the middle of the project, not at the end or anything. So here I'm saying our rate of performance is 50%. So 50% times the planned value of $2,000 gives us an earned value of $1,000. So in other words, we had planned on getting about $2,000 worth of work done. We only have $1,000 worth of work done, and we can see that reflected in the rate of performance of 50%. So all three of these numbers very closely related. Now, that's a look at the work that was planned to be done, just amount of work, but we also want to consider the amount of money that was spent, and we'll get that through actual cost. So cost variance then is earned value minus actual cost. If we see earned value of $1,000 and actual cost of $3,000, then our cost variance is $2,000. Notice that there are two different variables at play here. We're behind schedule by about 50%, as we see in our rate of performance, and therefore our earned value is 50% less than our planned value, and that's reflecting the schedule. On the other hand, our actual cost at this point was also greater than expected. Our actual cost is $1,000 over the planned value, but if you also factor in that we're $1,000 behind on a schedule basis, so that amount of work roughly, then the cost variance is $2,000, which is $1,000 for being behind schedule and $1,000 of being over budget. Now the schedule variance, okay, for that we're looking at the earned value minus the planned value. So there again we say, well, we had planned schedule-wise to have $2,000 worth of work completed at this time. We only have $1,000, so our schedule variance is $1,000. Both of these numbers negative to indicate that we are behind cost and behind schedule. In other words, we have a cost overrun and we have a schedule overrun, so those are negative. If it just happens that we're ahead of schedule and we're doing better than expected on budget, then these two numbers would be positive. Now, let's compute the cost performance index. So that's looking at the earned value divided by the actual cost. Once again, we have two things at play here. The earned value is a reflection of scheduling, and the cost is a reflection of our actual costs that we spent. If we're over budget, it's going to be reflected in that actual cost number. So if our earned value is $1,000 and our actual cost is $3,000, then our cost performance index is 0.333 continuous, or 33.3%. Any number less than 0 indicates that we have a cost overrun and or we're behind schedule. Any number greater than 1 indicates that we are doing better than expected, either on a schedule or a budget perspective. Now the schedule performance index, once again similar here, we're taking earned value and dividing it by planned value. So how much work did we do? $1,000 worth of work. How much work was planned? $2,000 worth of work was planned. So $1,000 divided by $2,000 gives us 0.5, or 50%. Once again, a number less than 1 or less than 100% indicates that we're behind schedule. A number greater than 1 or greater than 100% indicates that we are ahead of schedule. Now let's use these indices and see how we can use them to help us predict how our project's going to go. If our original budget was $10,000, we take that budget at completion and divide by the cost performance index of basically 1/3 or 33%, and we get an estimate at completion of $30,000. So we can see by looking at these metrics in the middle of our project, we can project out how the project will look at the end, how the budget's going to look at the end. Estimated time to complete, we take our original estimate of 90 days, divide that by the schedule performance index of 50% or 0.5, and that gives us an estimated time to complete of 180 days. So a lot of formulas. I think that the thing to really keep in mind here is that earned value is looking at effectively our schedule variance, and it's quantifying it based on the value of work we plan to deliver and the value of work we originally delivered. But when we say value of work delivered, we're not considering budget. We're just considering the value of work per the schedule that we thought would be delivered at that time and the value of work that was actually delivered at that time. We do start to consider budget when we take a look at cost variance. And that one is a little bit tricky because we have the two different variables at play there. We have the earned value, which is reflecting our any kind of schedule, what we've delivered versus what we expected to deliver. But then we also have the actual cost, which considers any kind of cost overrun. Similarly, the cost performance index is going to be taking a look at earned value over actual costs. So that's going to be looking at both schedule overrun and budget overrun. That's where I think it gets just a little bit confusing, is where we have both of those variables at play. On the other hand, the schedule variance, which is earned value minus planned value, is just looking at that difference in schedule. And the schedule performance index, which is earned value divided by planned value, again, we're just looking at a scheduling difference there. We know ideally that cost performance index and schedule performance index can be used to say, okay, given what we have left on the project, where do we think we'll end? And that's a good guideline. That's a good way to look for any red flags. But we do want to consider anything else that could happen in the future. It's not a perfect prediction that because this happened in the past, it's going to continue happening in the future. We could mitigate what caused the schedule overrun. We could mitigate what caused the cost overrun. Learning curve theory could play in making us more efficient. But then on the same note, there could be things in the future we don't know about. Things like a key employee quitting, or COVID, or anything that would come in and interrupt us. So it's a good guideline, but we want to keep reality in mind as well. So I hope this video helped to clear up and make understandable some of these earned value calculations. And I hope that's helpful to you. I look forward to reading your comments. Thank you.